Alright, so you want outlet power in your car, like you want to plug things in like you have at your home. This is going to be the video for you. Enjoy. So here is the potentially daunting engine bay here. You're going to have to learn a little bit about this. I'll run you through it. It'll be pretty simple. There's two devices that are pretty important here to learn about. The first one on my vehicle is located down in here. This thing, I'll touch it right here, down in there. You see that? This device is an alternator. You can't see with this video because the camera's not very good, but there's a lot of copper winding in there, and this alternator generates the current that your vehicle is going to use. It's an important piece. You're going to have to learn how much current it generates, and I'll teach you more about it later. But this one generates 60 amps, which is essentially like 700 watts or so, and some of that goes to the vehicle. The electricity from this alternator travels over toward the battery, which acts as a voltage buffer and stabilizes the voltage. Kind of evens it out, kind of like flattening out a table surface or something like that. And then from this battery, your current is going to travel to your inverter. Some people put their inverters like here. It's kind of dangerous. I mean, you can make a compartment for it to seal it from water and stuff, but an inverter is kind of a sensitive device. So I'm going to run mine into the vehicle. And fortunately on my vehicle, I don't know about others' vehicles, there's already like a rubber thingy right here. And you can take it out, or you can drill a hole in it like I've done, which is smaller than the cable that I'm going to run through, and run the cable through there, and you'll have a cable going from your battery to the inside of your car where your inverter is going to be. I'll show you what I'm going to do with the inverter. Let's record. Alright, so this is one of my inverters, and look at those outlets. Aren't they beautiful? Wouldn't you like to have that in your car? The spot I've chosen for it has adequate ventilation. It'll blow the air around with this fan. It'll get the heat up and around in there. We don't want this device overheating. I've chosen this spot for it, back behind the glove box area. I've already drilled holes in this bar here where I'm going to mount this. And it's just going to sit up there like that. The glove box is going to be right here, and people can put their feet back there and be comfortable. I like this spot. You choose your own spot. So you got these outlets here. You have an on-off switch, and normally you have an LED in there. I don't have it in there right now, but I'll have that later. And all of these items, you can place them elsewhere in your vehicle and still have the main box be wherever you want it. It just takes taking it apart and then extending the wires and picking adequate wires. And we'll run through how to do that. Then you stick your car back together, and then you got outlet power in your car. There's some special things we'll have to teach you about it, like next section, teach you a little bit about electricity and figuring out what kind of inverter you're going to need. So here we go. If you're drawing less than 120 watts of power, you can, if you have the adapter, plug your inverter directly into the lighter outlet. Remember that your inverter takes a bit of energy to stay afloat, and it's not totally efficient, and at lower energy draw levels it's going to be highly inefficient. So your device with your inverter on may take up more power than you expect. But if worst comes to worst, you'll just blow a fuse and you can replace that fuse. It's pretty cheap. and on your lighter socket, in case you're wanting to wire your very small sub 120 watt inverter directly to your wire socket, this center one, the center wire that goes toward the back dot way in the back here, that's the positive, and then the side, this stuff in here, and this connector right here, that is your negative terminal. Alright, so inverters, there's a whole variety of them. Some of them come with charge controllers attached to them, and unless you're installing a solar panel in your vehicle, you're probably not going to want one of those. I think the two most important things you're going to have to learn about inverters are how much power they can handle and what kind of power they give out. You've got pure sine wave inverters, which create really good power, which is similar to the utility company kind of power that they give you. It's got a clean change in voltage in between negative 110, if you're using 110, negative 110 and positive 110 voltage. It's got a clean wave if you measure the voltage over time. And it'll be safe for all of your equipment, unlike the alternatives. The alternatives are cheaper. They're much cheaper. They are modified sine wave or square wave or modified square wave, and they can be dangerous. Some devices don't work for very long on that kind of power, and they will die. So you can visit my tutorial and figure out which one you need. You're going to need to figure out how much power you require. That too you can get help with at the guide. Another thing about inverter requirements, if you want to power a drill or something with what's called an inductive load, which I frankly don't still understand, but it's in refrigerators, some refrigerators, a lot of household refrigerators. It's in motors, and I think it's in things with large capacitors that gather their electricity when you power them up or something like that. But with things with inductive loads, if you stick them in these inverters, it'll try to draw for a temporary period of time 3 to 7 times the amount of power that the device is rated at, and that can be a lot of power, and that can do some good frying on your inverter. So some inverters are built for it, but probably not the kind that you're going to be able to want to fit in your car. Look into it. I haven't seen many of those inverters around, so maybe get a higher power requirement inverter, significantly higher than the rated devices you're going to be powering if they have inductive loads.